So let's talk again about errors type 1 and 2. It's something we've addressed in our previous classes, but today we're going to get a little bit more in depth. You've seen these two distributions before, H0, H1 distribution. We bring them together, we zoom in, and here we go. So you know that H0 is showing us the world 0 distribution, a world in which the null hypothesis is true. And H1 is showing us the alternative hypothesis, right? A world in which anything but 0 is true. And that's how we get to the Bowser dilemma. Let's picture you're a bouncer and you have the mission to keep all the drunk visitors away from your club, okay? So you're the security guy. And that's how we get to the Bowser dilemma. So let's picture you're a bouncer and you have this mission, right? This mission of keeping drunk visitors away from your club. And because you're a very scientific bouncer, you're actually going to draw blood samples from people and you're going to stash them in a sample coming from the population of blood, right? So the sample is the blood sample. And the population is all the blood in this person's body, right? And you're taking samples from one person at a time every time they're entering the, your like club. I mean, the reason why I'm using this example is because you can't go and assess the entire blood from a person, like you'd have to kill them. So let's keep people alive and let's only get a sample of that blood. It's in the same way that we get samples from, like Instagram, right? But instead of sampling people, this time we're sampling blood, but it's pretty much the same idea. Okay, so let's rearrange our screen, and I can finally tell you, the rule that we're going to abide by is a maximum 0.1% alcohol in the blood, okay, 0.1% alcohol in the blood. So you can picture this. This is the maximum. And we're going to allow people to get drunk up to 0.1. If they are drunk above 0.1, we're going to tell them to fuck off. Now, there's a problem, which is there's random error, right? When you're drawing a blood sample, from a blood population of a body, there's some random error. Sometimes it could be that you're in an area of the body that has less alcohol for some reason, or if you're drawing sample closer to the liver, I don't know. There's many things that could happen that for some reason you're not going to have the exact same percentage of alcohol that's all throughout your blood. It's just going to be a percentage of alcohol in that area of your blood. Okay, cool. So sometimes it's going to be too much. Sometimes it's going to be too little alcohol, right? Coming through the needle. And that's okay because inferential statistics. So 0.1% is our cut point. And we know that in our hearts, that because of the random error, there's an error margin here, which means that let's say that you're a person trying to get into the club and you're following the fucking rules, like you're a great person and you have exactly 0.1% of alcohol in your blood. Sometimes they could send you away just because of the error margin of them drawing a blood sample with a little too much alcohol compared to your entire body. So it's not fair. And that's the problem that we're going to discuss. Because where do we set the cut point, right? If we have a cut point of 0.1%, do we set the cut point at exactly 0.1%? When do we send people home? That's the big question. So this is the story time. So Joanne is always drunk at exactly 0.12%, which means that out of the entire blood in her body, 12% is alcohol. Cool. So this is the population number. The cut point is 0.1%, right? So let's say Joanne goes to the club 100 times, meaning that she takes 100 samples, 100 blood samples, because every night she goes to the club, the bouncer gets a blood sample. Each of these white, dots, white boxes that we find here, they're like one night that she went to the club. Oh, it looks like a normal distribution. Yes, it does, because sometimes when the bouncer got the blood sample, lots of alcohol molecules came through the needle, sometimes not so many, right? It's nature. That's what happens. The problem that I'm trying to tell you is that 60 of those 100 samples got her kicked out, but 40 of those samples allowed her to stay. How's that fair? It's not fair. It's stats. And with stats, we have errors. So let's flip this. Flip it and zoom in. And this, H1, this is a world where Joanne has 0.12% alcohol in her blood, right? Let's draw H0. H0 is a world where Joanne has 0% alcohol in her blood. Where should we draw the line? So we're drawing the line here as 0.1% because that's what we've been told. And here we're working with a one-sided null hypothesis with a 95% confidence interval. So let's go to the sober Joanne world. And what I mean by that is now forget about Joanne being drunk, okay? Now we're going to enter a world in which Joanne is actually sober, right? It's a world in which Joanne drinks no alcohol at all, and this is the distribution for her, okay? It's also the H0 distribution, right? So we're working here with a 95% confidence level, which means that in 95% of the times, we're going to let sober Joanne into the club. So if sober Joanne goes to the club 100 times, she'll be let in 95 times, right? We're working with an alpha of 0.05, okay? When we're working with an alpha of 0.05, that means that we're going to reject sober Joanne 5% of the time. So these are situations in which some alcohol from her, like, lotion or whatever, or some alcohol that's naturally present in the body made it through the needle and made it seem like she was too drunk, a little too drunk. It was a sad coincidence, very unlikely to happen, but it happened. So this is a situation in which the bouncer thinks that sober Joanne is drunk, and it sucks, right? Because sober Joanne should be allowed to go into the club and dance to reggaeton if she likes, or whatever she's into. Not fair. So now let's get transported back to the world of drunk Joanne. Okay, so now let's say we're talking about drunk Joanne. So this is a parallel universe in which Joanne is drunk all the time, and we're switching over to H1. Okay, so back in that world that we were before. So this is a world with 0.12% alcohol in her blood consistently. In this world, we're going to reject Joanne 60% of the times, which is the right thing to do because she's drunk and she shouldn't be allowed in the club. This area here is called the power of the test. It's the amount of times that we correctly reject a false null hypothesis. It sounds very trippy, but it's just saying that, like, you know, if you're drunk, you're going to get kicked out of the club, and that's the right thing to do. That's the power of the test. And in this situation, because we set the cut point to 0.1%, 40% of the times, we're going to end up letting her in. We're going to end up letting drunk Joanne in. So this is what we call the beta. This is the chance of a type 2 error. Type 2 error is what we call a false negative, okay? So it's a situation in which the bouncer thinks that drunk Joanne is not drunk. He's going to say negative, she's not drunk, or she's actually drunk, okay? This is not fair either, okay? Really, really, really not fair. So let's go to the I don't know Joanne world, which is the actual world of the bouncer, right? When the bouncer looks at you at a club and he's drawing blood samples from you, he doesn't know if you're drunk or not. He doesn't know what the real population looks like, but we can use the knowledge that we drew from the two hypothetical scenarios that we just imagined now of drunk Joanne and sober Joanne. So we're going to do that. The bouncer dilemma. Now we don't know whether Joanne is drunk or sober, but we found a sample of 0.09% alcohol in the blood. Okay, so let's plug in that 0.09. It's represented by this vertical arrow here. This is 0.09, and the cut point is 0.1. So it's just below the cut point. Great. Well, here represented in yellow, we have our p-value of equals 0.06, representing that there's a 6% chance that this is sober Joanne, right? There's a 6% chance that this sample is coming from H0. This is sober Joanne. And there's a 94% chance that she's drunk, right? Because there's a 94% chance that this is coming from somewhere else, coming from H1, for example. So in this situation, look at the percentages, okay? There's a 6% chance that she's sober, and there's a 95% chance that she's not sober. What do? Do you consider that she's sober? Do you consider that she's drunk? Your bouncer self do, you know? Do we send her away? And we're going to be tempted to send her away because there's a 94% chance that she's not sober, right? But we can't do it. We have to let her in the club because we have to stick to our principles of 95%, which is something that we agreed upon in advance. And remember, that was the rule, and we have to abide by the rules. So where do we draw the line? We drew the line in kicking away 5% of the sober people. That's what we agreed upon initially. Okay, and in this case, if we're kicking away sober Joanne, so be it. We're a profitable business, and we have to keep the drunk people away somehow, and we have to draw the line somewhere. So this is what we did with the 95% confidence interval. When we did that, though, we also agreed that we would be letting in 40% of the drunk people, right, because of the hypothetical scenarios that we just drew in our minds. So the conclusion is messing with the confidence level is a trade-off, right? That's it.